Y-intercept. I plug in a 0 for x. My y-intercept is 0, 2/3, so I put that on the graph. Close to 1, a little further from 0, 0, 2/3. Horizontal asymptote. This is a bigger on bottom, y equals 0 situation. Horizontal asymptote is y equals 0. Factor. This thing doesn't factor. Domain. That comes from excluding my excluded values. My domain is the set of x's where x is not -3, or in interval notation it's everything from -infinity up to -3, also everything from -3 up to infinity. We just don't include -3. Next I would cancel. Nothing cancels. Finally I do, not finally, next I do the holes. My holes come from the things that cancel, so there's no holes. Then I do vertical asymptotes. Exclude values that did not cancel out. -3 is an excluded value, never canceled out. X equals -3 is a vertical asymptote. X-intercept comes from zeros of my numerator. There's none. There's no x value that's going to take that numerator and make it equal to 0. So no x-intercepts. Then if I have a point in one piece of my graph, either to the right of my vertical asymptote or to the left or between vertical asymptotes, I can use that point and make a graph that's really close to the vertical asymptote and really close to the horizontal asymptote and also hits the point. To the left of my vertical asymptote, I don't have a point. I'm going to need to plug in something like -4 or -5, an x value 1 or 2 to the left of the vertical asymptote. I get y equals 2 over, I plug it into any version of the function I want, simplified or not simplified, before canceling, after canceling, whatever's easiest. Here I get the point -5, -1. So my graph must look like this. While I'm at it, the range, every y value starting from -infinity, I keep hitting the graph. So -infinity all the way up until 0. 0, I don't ever hit the graph. But after 0, I again hit everything. So everything from -infinity up to 0, stop at 0, don't include 0, and also 0 up to infinity is the range.